We're going to be talking about GraphRag today. Jason's from Neo4j.
I'm going to show off a demo of a knowledge graph builder app that our team has been working on. And basically how it works is you take some sort of text data and you bring it in, and then you split it into smaller chunks. And then you hand those chunks to a large language model to create, in our case, it'll be two things, to create the embeddings that represent each chunk, right? And then you put that into, you got the vector embeddings that will eventually go into a data store. And in our case, we're doing this, and we're also using a large language model to take that chunk of data and pull out, or to identify any entities and what relationships should exist between those entities. So we're basically parsing that text data for graph-like data. And then we're taking those graph documents and we're putting those into the graph database as well. So both the embeddings and the nodes and relationships are being generated at the same time. In a two-dimensional view of vector data, it'll look something like this, right? You'll have lots of individual nodes with the text and the embeddings, and they won't be connected if you're just going the vector route. And this is, so I'll show this app in a moment, but I'm just going to go through these screenshots because the import process takes a couple minutes, and rather than us sitting for 3 minutes for it to complete, I just took snapshots of this process. So this is the UI of this particular demo app. And the code is open source, so you can check out this code for yourself. You can implement it, you can fork it, and grab some ideas. You can use it as you please. So this app, in a nutshell, it's got two main components. One is a React front end, which is the GUI that you saw, and the backend, which is running off it's a fast API Python server. And under the hood, it's using LangChain, which is a large language orchestration framework for kind of help managing all of the prompts and the other technologies all together into a sensible sequence. And the main technologies that this demo app uses is OpenAI, or you could use Gemini for running the LLM portion, and then diffbot for helping create the knowledge graph components from the text, and then of course Neo4j for storing the data. Okay, let's see. Tom asked a question here. GraphDB data schema is always hand designed. Are there automated ways to complex domains where AI infers the most relevant node and relationships definition? Example, LLMs be helpful in schema design. Okay, yes. So this is where this app is going. So yes, this is an active area of development. Various tools are starting to pop up to help take various types of data and turn it into a data model. At this stage, even with these tools, I would still, you still want to take a look at that data model that it creates after the fact. And I'll just continue with this, and then we can have that discussion. Okay, so here I'm just using the YouTube importer option. So this just takes a URL link of a YouTube video. And the YouTube video I'm using is recording of Eugen's talk from, I think it was 2 weeks ago with Changshe of Lance DB. I just put the URL of that in, I click submit, and this took about close to the 3-minute mark that was predicted by the system here. And there is a progress bar. So once you kick off, you can you can watch. But what you'll likely do is probably pick a few different items here on the left, and just you can upload it all in a batch. Okay. All right. So after 3 minutes, this completes, and you'll know it's complete when you see the completed status. And once that's ready, you can jump into any one of our visualization tools to kind of check on the data. So here is a screenshot of the data that was generated. And what I'll do now is I'll actually go to the actual workspace here. Okay, so so what we're looking at here is Neo4j's browser. This is kind of the primary tool for running Cypher commands, which is the query language for querying graph data. It is one of several query languages, but it is our query language. It was open sourced, or an open source version of it came out quite a few years ago. And sorry, sidebar. And as of last month, the ISO standard for a graph query language, the GQL, graph query language, which can be easily confused with GraphQL, and often is, but it is separate, right? So GraphQL is for kind of a REST API alternative, and GQL, just the acronym, represents the ISO standard for graph query languages, which looks a lot like Cypher. So if you were to start with either, you'll find switching between the two not that super cumbersome. Okay, so what I was trying to do was just notate the system to display the document as, or display the file name for a document, so that when I zoom in, I can see that here is what I pointed to, and all this data was created from the transcript from this video. Okay, so fortunately I'm a little sluggish between the screen share. Okay, so what we're looking at here, this is the data schema, right? So this isn't representing all the individual data as was represented in this view, but the data model, which was being asked about earlier, for like, this is the sort of thing that was handcrafted prior. And now you can see, with the help of an LLM, we can quickly create a pretty sensible data model here to start with. You wouldn't have probably added this many relationships if you were handcrafting this. You probably would have simplified the number of relationships, right? So if I try to peel this out, we can see just between concept and software. Actually, let me put it on the other side. It might be easier. Oop. I want to go here. Right, we have, let's see, all the, let's zoom in here, all the relationship types: resolve pain points, compact, follow, soft delete, upsert. Geez, did you guys talk about this much detail in talking about software and concepts? You did? I might have to rewatch that video. But anyways, it's easy enough to, so unlike other databases like SQL databases, like adjusting the data schema is actually not as difficult in a graph database compared to those systems. Like, all you really have to do is in your data is either find, all those relationships of a certain type. So like here, hopefully I don't execute this, but say if I'm looking for all, like, so I've got effect and effects, probably don't need both, right? So I could delete them. I want to do this, attach delete R, which would remove all these relationships, or better probably would be to rename them. But all you have to do is, as you're affecting the underlying data, this data model gets updated, right? This data model just represents all the actual relationships and entities you have in your data. So as you're updating that, this data model will update to reflect that. So you don't have to do sort of this pre-planning that you usually have to do with other databases. Unless, of course, you're adding in a lot of constraints and indexes to help speed up the queries later, then those you kind of have to turn those all off before you affect those systems and then put those back in. So one limitation of YouTube transcripts that I encountered while preparing this talk is that this is kind of what the transcript looks like. It is all the words that Eugene and Chang had said, but it did not actually identify who was saying what. So when I pull up this demo later, asking a chatbot about the content, it won't be able to answer questions about Eugene and Chang directly because it doesn't know who they are. Well, it knows a little bit about Chang because Eugene had introduced him. So if you were to do something like this, as a side note, my recommendation would be to run it through a system that is able to identify the speakers, and then take this text and build a knowledge graph off of this. I did a little experimentation with this with some side tools, and this worked pretty good in terms of identifying who said what. So just this sort of small sort of data cleanup helps immensely. Basically, what I'm saying is, as with all sort of data projects, the better the better your incoming data that you're working with, the better your end results will be in general. So this I use Descript. So Descript is I think it came out primarily as a podcast app. And so what I did is I just took the audio from the YouTube video and I just dumped that into Descript. And Descript took a couple minutes to identify, just to transcribe everything. And when it first goes in, it doesn't know the people any better than YouTube does. But it just goes speaker one, speaker two, and then because I know who the speakers are, I went in there and just kind of updated like, okay, speaker one is Eugen and speaker two is Chang. And I only had to do that once, and then it was able to more or less correctly identify everyone. It's not 100%, but it's like 90%. So it's much faster than kind of manually transcribing anything. And Descript also has a de-filler word tool that was also helpful. So there are a couple tools like this out there, but the one I used was Descript.